All right, let's review some of the main properties that we have, some of the main figures again. So if we have a kite, has some very cool properties. The major diagonal is an angle bisector on both ends. The line containing the major diagonal is a perpendicular bisector of the minor diagonal. Okay, among some other properties, that's some. Now notice that if you have a rhombus, it is automatically a kite by definition. Opposite sides are all four sides are congruent, so that gives you two disjoint pair of consecutive congruent sides, so it makes it a kite. But you can think of either one as being the major diagonal, and the other one as being the minor diagonal. So both diagonals are perpendicular bisectors of each other. It has rotational symmetry about the intersection of the diagonals, and it has reflective symmetry about the lines going through the lines containing each diagonal. So two lines of symmetry. So notice how the properties of a rhombus, it got a lot of those from a kite. But actually, it turns out we know that a rhombus is a parallelogram as well, because we proved an earlier theorem that said a quadrilateral is a parallelogram if and only if both pair of opposite sides are congruent. That makes it a parallelogram. One of the properties of parallelograms is that the diagonals bisect each other, but it also has opposite sides parallel. So notice how it inherits that from the earlier ones. Now, what about a parallelogram? Parallelogram has lots of cool properties, including opposite sides parallel, the definition of a parallelogram, but also opposite sides are congruent and the diagonals bisect each other, among other things, but they're not necessarily equal in length. Now what I want to do is, what about a rectangle? Okay, so a rectangle has equal angular. Well, from that, we can just, the fact that all four angles are congruent, we can get from that that all four angles are actually right angles in Euclidean geometry here. It has lots of cool properties, including the diagonals will bisect each other because it's a parallelogram, which you can prove pretty quickly. And you get opposite sides congruent because it is a parallelogram. Now, if another thing we want to look at is an isosceles trapezoid. One of the properties an isosceles trapezoid has, in addition to having basically just two sizes of angles which are supplementary, two consecutive pairs that are parallel and two consecutive pairs that are supplementary, um, we get congruent diagonals there. Okay, well, think about it a minute. If it's an isosceles trapezoid and a parallelogram, that happens if and only if it is a rectangle. So a rectangle has all the properties of both a parallelogram and the properties of an isosceles trapezoid. So the diagonals bisect each other and are congruent. Since it's a parallelogram, they bisect each other. Since it's an isosceles trapezoid, they're congruent. Also, from the properties of parallelogram, opposite sides are parallel and congruent. So as soon as we prove that a rectangle is a parallelogram, not part of the definition, but something we can prove, then we get all the properties of a parallelogram. And then pretty quickly we get that it's an isosceles trapezoid as well. Now, a rectangle was an equiangular quadrilateral. A rhombus was an equilateral. If it's both of those things, it is a square. So square has lots and lots and lots of interesting properties. Actually, a rhombus has lots and lots of interesting properties as well, but square has all of those plus all the properties of a rectangle. Well, since it's also an isosceles trapezoid, the diagonals are congruent to each other. Since it's a parallelogram, the diagonals bisect each other. How do I know it's a parallelogram? Well, one of the things we proved was if both pair of opposite sides are congruent, then it must be a parallelogram. Well, if it's equiangular, it's also a rectangle, so those are all four right angles as well. Now, since then this makes it a kite as well, right, with either diagonal being the major diagonal, the diagonals are not only, they're actually perpendicular bisectors of each other. And actually we have four congruent right triangles showing up here. For example, AXB, BXC, CXD, and DXA are all four congruent right triangles. And each of these diagonals is an angle bisector on each end, breaking these up so that actually not only these are four right congruent right triangles, they're actually 45 degree, 45 degree, 90 degree triangles, or pi over 4, pi over 4, pi over 2 radian triangles. Okay. Um, and it turns out that all squares are similar to each other. They're just a dilation of each other, getting bigger or smaller this way. So, as Huey Lewis and the News say, it's hip to be square. Lots of cool properties there. Okay. And notice that proving them is pretty easy because it just automatically inherits, it's automatically by definition, it's a rhombus and a rectangle. So it includes all the properties of a rhombus, all the properties of a rectangle combined together. Okay, so I think that kind of concludes then my look at these different things where we looked at classifying by congruent triangles, number of position of congruent sides, number of parallel sides, number of congruent angles, number of right angles, number of position of supplementary angles, circle relationships, diagonal properties, and a square which has almost all the properties we talked about. Or we could go all the way back to the general one, definitions, and this hierarchy graph here, you can see where all these things kind of land together. And so that concludes this little section of videos going over the things that are included in this one big uh, uh, classification thing here. If you look here, you can see if you want to see the direct web address to this right there, this will uh, get you to the GeoGebra thing here. It's available for anyone to use.